Hello everyone, I am Mohammad Shakib from Sri Venkateshwara College of Everyone Engineering. Today's subject is COA and the subject code is BEC306C, Cache Memory and its Organization. Today's topic is Cache Memory and its Organization. Introduction. Cache memory is a high speed storage component located between the main memory, that is RAM, and the CPU. Its primary purpose is to temporarily hold frequently accessed data and instructions, enabling faster data retrieval and improved overall system performance by storing copies of data from the main memory. Cache memory reduces this time it takes for the CPU to access information, minimizing latency. Cache memory is typically divided into multiple levels L1, L2, and sometimes L3. L1 is the smallest and fastest, located directly within the CPU. L2 and L3 are larger and slightly slower, often found on the CPU chip or close to it. The hierarchical structure allows the CPU to quickly access the most frequently used data, significantly speeding up processing times. What is cache memory? Cache memory is a small high-speed storage area located between the CPU and the main memory, that is RAM. It temporarily holds copies of frequently accessed data and instruction to speed up data retrieval, because accessing data from cache is much faster than retrieving it from the main memory. Cache memory significantly improves the overall performance of the computer system. Cache memory is organized in multiple levels, that is L1, L2, and L3. The fastest and smallest located directly in the CPU. It provides quick access to the most frequently used data. L2. L2 cache, larger than L1 but slightly slower. It may be located on the CPU chip or close to it. L3 cache, even larger or slower, often shared amongst multiple CPU cores. By reducing the time it takes for the CPU to access the data, cache memory plays a crucial role in enhancing system efficiency and responsiveness. Cache memory organization. Cache memory is organized in a hierarchical structure to optimize data retrieval and improve performance. Here's a breakdown of how cache memory is typically organized. Levels of cache. L1 cache, location integrated directly into the CPU. Size typically between 16 kilobytes to 128 kilobytes. Speed, fastest access time, usually measured in nanoseconds. Function, stores the most frequently used data and instructions for quick access by the CPU. L2 cache, location can be on the CPU chip or nearby. Size, generally larger than L1, ranging from 256 kilobytes to several megabytes. Speed, slower than L1 but faster than L3. Function, acts as a buffer for L1 cache, storing additional data and instruction that are frequently accessed. L3 cache, location often shared among multiple CPU cores. Size, larger than L2, often several megabytes up to tens of megabytes. Slower than L1 and L2 but still faster than main memory. Function, reduces memory access times for multiple cores, storing data that may be needed by different cores. Cache memory. Cache memory is organized into blocks called cache lines. Each cache line typically holds a fixed amount of data, example 64 bytes, and the CPU registers data, entire cache line are loaded into cache memory even if only a small portion of the data is needed. Associativity. Cache memory can be organized in several ways based on associativity. Direct mapped cache. Each block of main memory maps to exactly one cache line. This is simple but can lead to conflicts if multiple blocks map to the same line. Fully associative cache. Any block can be stored in any cache line, providing maximum flexibility but requiring more complex circuitry. Set associative cache, a compromise between the two where the cache is divided into sets and each set contains multiple lines. A block can be stored in any line within the specific space. Write policies. Cache memory also uses different strategies for handling writes. Write through data is written to the both the cache and the main memory simultaneously. Write back. Data is written only to the cache initially within the main memory, updated later, reducing write cycles to the slower memory. The summary of the cache memory and its organization. The organization of cache memory with its hierarchical structure, cache lines, associativity, replacement policies, and write strategies is crucial for optimizing the speed and efficiency of data access in modern computer systems.